Hello everyone, Peter Newman with you for AHRI Insight this week. We had a good question from WA agronomist Tim Boys, who was asking, should I use Axial or Achieve type herbicides in my cereals, or should I save it for the clethodim? And so he had a resistance test that showed that he could get about 50% control of a population of ryegrass with Axial. He had big numbers and was wondering, should he spray it and get that 50% control, or should he be really strategizing and thinking about saving those shots for the clethodim? So we had a go at answering the question, but then we thought we really need to dig into the science here. So we went back, looked into the archives and found a paper by AHRI researcher Qin and others that really explains what's going on with the target site mutations to clethodim and other dim and den herbicides. So let's take a look at it. So let's start down at this bottom here. So this is just a chart that sort of shows the clethodim resistance level for a range of target site mutations. So the 1781 mutation here is the most common target site mutation for the dim and den type herbicides. And down here we have a heterozygote. So we've got two copies of each sort of gene in a diploid plant like ryegrass. And in this case here we have a heterozygote. So one copy of the gene is the resistant type and the other copy is susceptible. So the point being is that a plant with this target site mutation, a heterozygous 1781 mutation, could survive a dim or a den herbicide that you would spray in cereals, like an Achieve or an Axial. So this plant could survive Axial in cereal. However, clethodim will control it. So what are we worried about? If we spray the dim or den in the cereal and then we make these heterozygotes, then next year we can just kill them in the break crop. Who cares? Well, it gets more interesting than that. So we have other target site mutations. So we have the 2078 mutation here. That shows that even though it's still a heterozygote, it's a different mutation. It's a slightly stronger resistance level. But 250 mils of clethodim will control these. But what happens is if we spray a dim or a den in a cereal crop and we have some survivors with these mutations, with these heterozygous mutations, they will cross-pollinate in that cereal crop, resulting in some homozygous survivors. So homozygous being two copies of the gene, like a purebred with that target site mutation. So then we get this elevated level of clethodim resistance. So if we have a 1781 mutation that is homozygous, that is 18-fold resistant to clethodim. If we have a 2078 mutation that is homozygous with that mutation, it is 41-fold resistant to clethodim. And if we have this here is actually the 2088 mutation, that's even higher level, 48-fold resistance to clethodim. So what happens if we use those dims and dens in that cereal phase? We can create these heterozygotes, they cross-pollinate, create some homozygotes, and they are sort of priming the ryegrass to evolve this higher level resistance. So it doesn't spell the end of our dims and dens in cereals, but if you are in a farming system that uses break crops and you're heavily reliant on clethodim surviving into the future, then it probably is a good idea to give those dims and dens a miss in that cereal crop and save it for the break crop. That's going to be up to you. But really it's just very important to understand the science behind it, that it is all about the target site mutation and whether it is heterozygous or homozygous. But for more information, check out AHRI Insight, and thanks Tim Boys for the question.